Okay, so we're going to go ahead and see this balance scale thing in action when it comes to math and when it comes to solving our equations. Okay, so here I see that I have x plus 13 equals 21. Okay, so right now that scale is balanced out. Okay, it's balanced, it's nice and even, and we know it's balanced because we have the equal sign here. That equal sign tells us that whatever's on one side is the same as what's on the other side. Okay, I want to go ahead and find out what this x equals. In order for me to get that x, find out what that x equals, I have to make it so that it's by itself. Okay, so I got to get rid of what's with the x. In this case, I have 13 with the x. Okay, so for me to get x by itself, what I have to do is I have to subtract 13 from the side. I have to go ahead and subtract 13. Okay. Now, let's see what happens once we take 13 off that side. So now we removed 13, and this scale has become unbalanced. We have x over here, and we have 21 over here. They're not equal anymore because we removed that 13. Okay? So now I need to make sure we get our scale back balanced. Okay? And in order to do that, I'm going to have to subtract 13 from this side also. Okay, so if I subtracted 13 over here, I have to subtract 13 over here. Let's see what happens when we do that. We get 8 on that side, and this scale is now balanced out again. Okay, it's balanced out. So now we know that x equals 8. Okay. What we just did was called inverse operation. Okay, we did the inverse operation in order to figure out what x equals. Okay, so to better understand inverse operation, let's take another problem. X plus 72 equals 134. Okay, I have to figure out what that x equals. So in order for me to figure out what that x equals, I need to make sure that I get it by itself. Okay, so now I'm going to do the inverse operation. What I always like to do whenever I do problems like this is I like to do tracks like this, because what that's going to do is that's going to force me to go ahead and say, okay, whatever I'm doing on one side, I'm doing on the other. Okay, I have to make sure that I keep balance. Okay, so over here I'm going to do minus 72. Okay, what that does is that cancels everything out, and now I'm just left with my x. Okay, but remember what we said. Whatever you do on one side, we have to still make sure we do on the other side over here. So I have to go ahead and I have to subtract 72 over here. Okay, and I'm going to go ahead and finish this off. 4 minus 2 is 2. 3 minus 7 I can't do, so I borrow from that 1, and this becomes 13, right? And I have 6. So x equals 62. That's using inverse operation. Okay. Okay, this time let's go ahead and look at inverse operation, but let's look at inverse operation with a subtraction problem. Okay. All right, so now I'm going to do my x minus 12 equals 26. Okay, x minus 12 equals 26. I'm going to do this where I do my train tracks again. so that I know that I'm doing the same thing on both sides the whole time. Okay. So here I look at my operation is minus 12. So my inverse, my reverse operation of that is going to be addition. So I'm going to add 12 on this side, and that ends up giving me the x all by itself. But whatever I do on one side, I have to make sure that I do on the other side. So I have to go ahead and add 12 over here. Okay, and when I go ahead and add 12 over there, I see that x will equal 32. Sorry, 38. 38. 6 plus 2 is 8. 2 plus 1 is 3. X equals 38. So that's how we work it with it, subtraction.